All right, so continuing on with 2.1, so talking about functions. So here we have a piecewise function. So in this function is defined like piecewise implies where it's defined in two different pieces. So when x is less than 0, the value of the function is dictated by x squared. When x is greater than or equal to 0, the value of the function is dictated by x plus 6. So when you're evaluating these functions at particular values, you have to consider what piece are you on. So when x is less than 0, it's x squared. So here we have uh, f of -2, and of course these are the x's that we're looking at. Number in parentheses always refers to the x. So f of -2, this is going to be looking at the x squared because -2 is less than 0. So -2 squared, and that would equal 4, of course. -1, again, -1 is less than 0. So this would be -1 squared, which is 1. F of 0, 0 is greater than or equal to 0. So here we're going to plug it into x plus 6. So we have 0 plus 6, and that gives us 6. And then same thing with these two. 1 is greater than or equal to 0. So 1 plus 6 is 7. And then 2 is greater than or equal to 0. And that would equal 8. And so now, so that's piecewise functions. We may see piecewise functions some more later on, but they're not too complicated. They can be maybe a little bit trickier to graph, or at least they take a little bit longer to graph if you're graphing by hand. But as long as you understand, you have to look at where your x is, where is this value, which piece are you looking at, then they're not too bad. All right, so net change. So the net change in the value of a function is as the input changes from A to B is given by the formula f of B minus f of A. So we're really just looking, if you have a graph, and we'll just draw some curve here. And let's say that A is right there, and let's say that B is right there. And so there is our f of A, and there is our f of B. How much is that changing? Basically, what is the vertical change here? So obviously the change would be that, but if we're just talking about the net change of f, that would be the vertical. We're talking about a vertical change. So how much did that graph just move up? We're not talking about the horizontal change. We're just talking about the vertical. So how much did it move up? So there's your y value f of b. There's your y value of f of a. What is that distance? That's what the net change is telling us. All right. So last thing we'll talk about in this section is the domain. And it's very important with domain. You need to make sure you pay attention to what type of function we're looking at. So we're, of course, going to learn throughout this semester many different types of functions. But there are pretty basic rules to finding these domains. For instance, this is a rational function. So whenever you have a x in the denominator like this, we're typically going to be talking about a rational function. And if you think about what do you know about fractions, so rational is referring to fraction. Rational numbers is referring to fractions. Rational functions are referring to fractional functions, or typically one polynomial over another polynomial, which we'll talk about polynomials a lot. So with a rational function, when we're talking about the domain, the denominator cannot equal 0. So when you have a rational function, the denominator cannot equal 0. So we're just going to set this denominator equal to 0, solve for x, is usually pretty easy. And the domain is everything else. So the domain of this one is everything except 4. And so we're going to write these in interval notation. So -infinity up to 4, parentheses, because we're not including the 4. So remember brackets, when we're talking about interval notation, bracket would mean we're including the 4, parentheses mean we're not. And infinity, of course, and negative infinity always has parentheses. And then we're going to do a union. So the union means or. So X is either in this interval or it's in this interval. And we're only excluding the 4. So we're going to go all the way up as close as we can get to 4, skip over that 1 point, and then go from 4 to infinity. And that is our domain. So whenever you have a rational function, that is all you have to do. What about a square root? Square root, what do you know about square roots? And we're dealing with real numbers here. With square roots, you cannot take the square root of a negative number if you're only dealing with real numbers. So what we need to do is set this part greater than or equal to 0. So whatever is under the root, under the radical, set it greater than or equal to 0. And you would solve for x if you needed to, but in this case, we just have x greater than or equal to 0. So the domain is 0 to infinity. In this case, we are including 0, so we use the bracket. So it is possible to take, you can take the square root of 0. Square root of 0 is just 0. So that is fine. So with square root, set that whatever is under this radical greater than or equal to 0. And then you have to solve for x, and then the domain is whatever that inequality gives as the solution. So part C, here we have another rational. So we're going to set the denominator equal to 0 and solve for x. And if you need a review for solving quadratics like this, I think there's a section in chapter 1. We skip over chapter 1 because that's a lot of basic algebra stuff. But if you need help, like if you see anything like this where you have trouble remembering how to do equations like this or whatever it might be, look through section 1 or chapter 1, and there's probably a section that covers that, and you can refresh your memory on how to do these. But with this, we can factor out an x, and we're left with x times x minus 1. And so we get x equals 0 and x equals 1. So these are the 2 points where our domain is not. So it's everywhere else. So you think of it like we have a number line, we have 0 on here, we have 1. We want to get rid of those points. We don't want those points. And we want everything else. So negative infinity up to 0. Parentheses. These will always be parentheses because we're taking out a point. Union 0 to 1. Union 1 to infinity. And so however many points you have when you're solving the rational function denominator, however many solutions you have to this, you're going to have one more interval than that. So here we had one solution solving that. We had 2 intervals. Here we have 2 solutions. We have 3 intervals. So however many you have, and I don't think you'll probably have more than 2. You have one more interval than that in your domain. All right. So now let's look at this one. So this one is a square root. So you're going to set what is under the radical as greater than or equal to 0. And so we can bring the 9 over. And I typically like to keep the x's on the left side when you're doing inequalities. If this was an equation, I'd probably just bring the x over there. But with inequalities, I typically keep the x on the left side. Then divide by -1. Now, when you divide by negative, you got to flip the inequality and then take the square root, and we get x is plus or minus 3. Now here, this is not a linear inequality, so really the inequality part is not that important when we're solving for this. So what we're going to do is, and we'll have to do this at different points in this semester. Our solutions are 3 and -3. Now, the square root has to be positive. So where would this be positive? So you can try test points. So just pick a number that's less than -3. So like say -4. If you plug in -4, so 9 minus -4 squared, that would be 9 minus 16. That is less than 0. So we don't want any numbers over here. So those are no good. Pick a number between -3 and 3. So like 0. Plug in 0 for x, you get 9 is greater than 0, which is true. Plug in a number greater than 3. So like say +4, you just end up with the same thing. So that doesn't work. So here the domain is -3 to 3. And with square roots, you include it because you can't, we have the equal here, so we're including the 0. Again, if it's -3, you get 0 under the radical, and that's fine. So that would work. So the domain here, -3 to 3, we're testing points. So just see wherever, pick a number in each of these sections. So we don't need to pick 3 and -3. We know that those would be included because of the equal part here. So pick a number just in between these numbers or outside the numbers, and you plug it in, see if it does what you want it to do, which that's what we're looking at. Plug in a number, see if it's greater than or equal to 0. If it is, then it's in the domain. If it's not, then it's not in the domain. And we'll probably get more practice with those this idea later. All right. So this one, last one, is a square root and rational. So square root and rational. So now with square root, you would say t plus 1 is greater than or equal to 0, but we don't want 0 on the bottom, so we're not going to include 0 this time. So just solve this. T is greater than -1, and so the domain is -1 up to infinity. And so again, with these domain problems, you have to identify what type of function you're looking at. If you ever see absolute value or a polynomial, or we'll look at exponential functions later, these all have different rules than what we saw here today, but we'll get to those as we need them. But for now, just the square roots and the rational square roots, whatever's under the radical, set greater than or equal to 0 and solve. For rational, set the denominator equal to 0, and then whatever x is from that, take those points out. So if you have any questions, feel free to email me, and I will answer those as quickly as I can.